The sun, a giant ball of plasma, fusing hydrogen into helium for billions of years. This nuclear powerhouse dictates life on Earth. Its energy fuels our days, drives our weather, and captivates our imagination. But the sun is not a silent, benevolent giver. It is a dynamic, sometimes volatile, celestial body. Our sun is a yellow dwarf star, one of billions in the Milky Way galaxy. Don't let the dwarf fool you, though. It contains 99.8% of the mass in our entire solar system. Light from the sun, traveling at an incredible 186,000 miles per second, takes about 8 minutes to reach us. This means we are constantly bathed in the afterglow of events that happened millions of miles away, just moments ago. Understanding the sun is not just about unraveling the mysteries of the cosmos. It's about understanding our place in it. Our very existence is intertwined with the sun's activity. It dictates our past, present, and future. As we delve deeper into the heart of our star, we gain a profound appreciation for its power and the delicate balance it maintains in our solar system. For centuries, we observed the sun with the naked eye, tracking sunspots and eclipses. Today, sophisticated telescopes and spacecraft offer an unprecedented glimpse into the sun's dynamic behavior. We are living in a golden age of solar physics. The Solar Dynamics Observatory, launched in 2010, provides high-definition images of the sun every 10 seconds. This constant surveillance allows us to study solar flares, coronal mass ejections, and other solar phenomena in unprecedented detail. Meanwhile, the Parker Solar Probe, launched in 2018, is on a daring mission to touch the sun. It will fly closer to the sun than any spacecraft before, braving intense heat and radiation to unlock the secrets of the solar wind. These missions and others like them are providing a treasure trove of data. Scientists are using this data to build more accurate models of the sun's behavior. These models help us understand the underlying physics of our star and, crucially, improve our ability to predict space weather. Imagine a sudden burst of energy equivalent to millions of atomic bombs detonating simultaneously. That's a solar flare, a powerful explosion on the sun's surface. These events are awe-inspiring displays of the sun's raw power. Solar flares occur when magnetic energy that builds up in the sun's atmosphere is suddenly released. This energy heats the surrounding plasma to tens of millions of degrees, causing it to emit radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. Fortunately for us, Earth's atmosphere shields us from the most harmful effects of this radiation. While visually stunning, solar flares can disrupt radio communications on Earth. They can interfere with GPS signals and even pose a risk to astronauts aboard the International Space Station. Understanding these events is crucial for protecting our technology and ensuring the safety of future space travelers. If solar flares are the sun's warning shots, coronal mass ejections, CMEs, are its heavy artillery. These events involve the ejection of billions of tons of solar plasma into space at speeds of millions of miles per hour. This material, carrying with it a piece of the sun's magnetic field, can reach Earth in a matter of days. When a CME hits Earth's magnetic field, it can trigger a geomagnetic storm. These storms can be both beautiful and disruptive. They are responsible for the dazzling auroras that light up the sky at high latitudes. However, they can also induce currents in power grids, potentially causing widespread blackouts. The most famous example of a CME's impact on Earth is the Carrington event of 1859. This powerful geomagnetic storm caused telegraph systems worldwide to fail, with some operators reporting electric shocks and even fires. If a similar event were to occur today, the impact on our technology-dependent society would be significant. Auroras, also known as the northern and southern lights, are captivating celestial displays. These shimmering curtains of light, often green, red, or purple, dance across the night sky, mesmerizing observers. But what causes these ethereal displays? The answer lies in the interaction between the solar wind, CMEs, and Earth's magnetic field. When charged particles from the sun collide with atoms in Earth's atmosphere, they excite these atoms, causing them to emit light. The color of the aurora depends on the type of atom being excited and the altitude at which the collision occurs. Auroras are most commonly seen at high latitudes, near Earth's magnetic poles. However, During intense geomagnetic storms, they can be visible at lower latitudes as well. These mesmerizing displays are a testament to the interconnectedness of our solar system and the awe-inspiring power of our sun. Section 6. Impacts on Earth technology at risk. Our technological civilization is increasingly vulnerable to the whims of the sun. Solar storms, while beautiful, can wreak havoc on our interconnected world. Power grids, communication systems, and satellites are all at risk. A powerful geomagnetic storm could induce currents in power grids, causing transformers to overheat and fail. This could lead to widespread blackouts, potentially lasting for days or even weeks. Communication systems, reliant on radio waves and satellites, could also be disrupted. GPS signals, crucial for navigation and timing, are particularly vulnerable to interference from solar storms. The economic impact of a major solar storm could be devastating. In 2012, a study by the National Academy of Sciences estimated that a Carrington-level event could cost the U.S. economy alone trillions of dollars. As we become increasingly reliant on technology, the stakes only get higher. Section 7. Predicting space weather. Just like we forecast the weather here on Earth, scientists are working to predict space weather. This involves monitoring the sun's activity, understanding the behavior of the solar wind, and developing models to forecast potential impacts on Earth. Space weather forecasting is still in its early stages, but significant progress has been made in recent years. Agencies like NOAA and NASA issue space weather alerts and warnings, providing crucial information to satellite operators, power grid managers, and other stakeholders. Accurate space weather forecasting is essential for mitigating the risks posed by solar storms. By providing advance warning, we can take steps to protect our critical infrastructure, such as power grids and communication systems. Section 8. The future of solar exploration. The quest to understand the sun is far from over. New missions and technologies are on the horizon, promising to revolutionize our understanding of our star and its impact on Earth. The Daniel K. Inouye Solar Telescope, located in Hawaii, is set to become the world's most powerful solar telescope. Its advanced optics will allow scientists to study the sun's magnetic field and solar activity in unprecedented detail. Meanwhile, the European Space Agency's Solar Orbiter mission will provide the first-ever images of the sun's poles, offering new insights into the sun's magnetic cycle and its influence on space weather. These missions, along with advancements in modeling and data analysis, will usher in a new era of solar physics. We are on the cusp of unlocking some of the sun's most closely guarded secrets, paving the way for a future where we can better predict and mitigate the impacts of space weather. Section 9. Safeguarding our future. The importance of solar research. The sun, our nearest star, is both a source of life and a potential threat. Understanding its behavior is not just an academic pursuit, it's crucial for safeguarding our technological civilization and ensuring the safety of future space exploration. As we venture beyond Earth, whether to the Moon, Mars, or beyond, we will be exposed to the full brunt of the sun's fury. Solar storms can pose a significant risk to astronauts and spacecraft, highlighting the need for accurate space weather forecasting and effective mitigation strategies. Investing in solar research is an investment in our future. By unraveling the mysteries of our sun, we can better protect ourselves from its wrath, harness its energy more effectively, and ensure a brighter future for humanity, both on Earth and among the stars.